Here we're going to calculate the NPV of a project, and in this particular case, we're going to have cash flows that continue on indefinitely, and so we're going to have to take care of that by making some assumptions, and the assumptions are actually already given in the problem, so that'll be pretty straightforward here. But let's go ahead and get started by jotting down timeline. So here's what we know, and I'll write these numbers in thousands to save space. So we know the first four cash flows, the first four inflows are these numbers in 1 through 4. But then we also know, and I'm just going to go to infinity out here. These cash flows are going to grow at 4% forever. 4% per year forever. And so when we got cash flows going on forever, we typically have to embed some assumptions about what the forever nature of the cash flows is going to be. And that's already given in this problem. So we've got a growing perpetuity starting from year 4 onward. And so what we'll do is we're going to create what we call a terminal value, and that's just going to be the present value of all future cash flows from some point forward. And in order to calculate that terminal value, we're going to rely on an assumption like this one. They're going to grow at a constant rate forever. An alternative way to do this might be to say cash flows are going to be constant. Here, they're going to be growing at a constant rate. So we're going to have a growing perpetuity. And so we know that at some point, we're going to be able to create a terminal value. And so we'll call that TV. And that's going to be equal to the cash flow one period into the future divided by a discount rate minus the constant growth rate. And since our cash flows are growing at a constant rate from time 4 forward, we're going to use time 4 as our first cash flow, which means our terminal value is going to be at time 3. So calculating the present value at time 3 of cash flows 4 through infinity, we're just going to use this Gordon formula. Let's go ahead and do that calculation. So our terminal value at time 3 is going to be our cash flow at time 4. So that's 131. We're going to divide that by the discount rate, or the cost of capital, which is 9%, minus the growth rate. And we get 2620. Okay. So again, writing all this down, it's going to be 131 divided by 0.09 minus 0.04. And that's going to equal 2620. And so think about where 2620 is going to go on this timeline. That number is going to go right here, the time 3 cash flow, and it's going to cover everything, all the cash flows after time 3. We'll go ahead and go back into blue. We'll say 2620 as our terminal value at time 3. And so we now have reduced our project to this set of cash flows here. And so from there, we can now find our NPV. Now our calculation becomes pretty simple. We're just going to calculate the present value of each one of these cash flows individually and add them up. I'm going to use my cash flow register to do this. That's the CF key. Now I hit the CF key. I can see that I've got some junk stored in here, so I want to clear everything out first. So second, clear work. Now I can enter my blue numbers one at a time. So 8, 3, 1 with a negative sign. Push enter, that's CF0. Now let's go to CF1. Enter 133. F is 1 because the frequency is 1. Moving on to cash flow 2, so I have 110. There's one of those. Cash flow 3. Now here I'm going to enter both of these together. So I'm going to say 190 plus 2620 equals this number. So that's my cash flow at time 3. So I'll push enter. And there's one of those as well. So now I can scroll back through and I can see that all of my cash flows are entered. Now to calculate NPV, push the NPV button, give it 9% as my discount rate, and compute NPV. And there is my answer.